calculate the value of RL which will absorb maximum power from the circuit of figure. Also compute the value of maximum power. So here we have to calculate the value of this RL which will absorb maximum power. Also we have to calculate maximum power. Solution. Now here we can see this is a current source in parallel with resistance. So using source transformation we can simplify this circuit. We can convert this current source into its equivalent voltage source. So here we will convert this current source to voltage source. This will be of 5 ohm. Then here this will be a voltage source. The polarity for voltage source will be positive here and negative here according to the direction of this current. Now we know that V is equal to I into R. I is 6 ampere into R is 5 ohm. So this will be 30 volt. Now for maximum power transfer to take place, RL should be equal to RTH. RTH is the Thevenin's resistance. So we can find this Thevenin's resistance. To find RTH, we will redraw this circuit. Now here we have to find RTH. So to find RTH, first we have to remove this RL. And this will be our RTH. Also we have to turn off all the independent sources. So here we can see this is a independent voltage source. So when we turn off independent voltage source, that time it will be short circuit. Also this is also a independent voltage source. So when we turn off this independent voltage source, that time it will be short circuit again. Now RTH is equal to 5 ohm parallel with 10 ohm. 5 ohm parallel with 10 ohm. So this will be 5 into 10 divided by 5 plus 10. So 5 into 10 divided by 5 plus 10. So it is 3.33. 3.33 ohm is the value for RTH. Then RL should be equal to RTH for maximum power transfer. So RL is equal to RTH is equal to 3.33 ohm. Then next we have to compute the value of maximum power. So for maximum power, the formula is P max is equal to VTH square divided by 4 RTH. So we have the value for RTH, but we don't have the value for VTH. So we have to find VTH. To find VTH, again we have to redraw this circuit. To find VTH, we have to remove this RL and this will be our VTH. This will be VTH. This will be positive and this will be negative. So first we have to find this voltage, this VA. Let's say this is a ground node. Let's say this is current I1. So I1 is equal to this voltage, that is 120 minus 30 divided by I is equal to V by R. So V is 120 minus 30. Then R will be 10 plus 5. So 10 plus 5. So 120 minus 30 divided by 10 plus 5. So it is 6. The value for I1 is 6 ampere. Then let's say this is loop number 1. So here we can apply KVL. Apply KVL to loop number 1. Let's say we will start from here. So this will be minus 120, minus 120. Then this will be positive, this will be negative. So plus 10 I1. Plus 10 I1. Then plus VTH is equal to 0. Plus VTH is equal to 0. We also have the value for this I1. So this will be minus 120 plus 10 multiplied by I1 is 6 plus VTH is equal to 0. So this will be minus 120 then plus 10 into 6. So it is minus 60 plus VTH is equal to 0. So therefore VTH is equal to 60 volt. Now we have the value of VTH and RTH. So from this we can find the value for P max. P max is equal to VTH square divided by 4 RTH. VTH is 60 square divided by RTH is 4 into RTH. The value for RTH is 3.33 ohm. 3.33. So this will be 60 square divided by 4 into 3.33. So it is 270.27. The unit for power is watt. So therefore P max is equal to 270.27 watt. So this is the final answer. What we have to calculate? We have to calculate the value of RL, which will absorb maximum power. So the value for RL is 3.33. Then next we have to compute the value of maximum power. So the value for maximum power is 270.27 watt.